Okay, static. As I said, this maths thing, really, these are pure functions. So they really should be defined to be static. And here's how I do that. You just put the static keyword in. And now there's one per class. Now Java has a little wart in my view. Okay, Java will actually let you do this, but one way to prevent that. Okay, so I don't want now. I don't want anybody to instantiate this. So here's my trick. Oops. Okay, so you see what I've done is I've declared my constructor to be private. Remember, if something is private, I can only access it from within that class and nowhere else. And so as soon as I save this, I get a red squiggly. Why? Well, let's see what it says. It says maths has private access. Okay? So now I can't instantiate one. And in this case, I don't want to because maths is actually, I'm presumably designing it to be a class that only has pure functions in it. And so this is no good. Now, okay, here, can't find the symbol. Why? Because I haven't defined, I've deleted it. But remember, how do I invoke a static method? With the name of the class dot the name of the method. And squiggly goes away. Oops, not. You're all too young to remember Johnny Mathis, but that's okay? Well, okay, so now this is the what. The what is, remember, instance variables object.method, class methods class.method. And now the Java has kind of a wart where they will they will actually allow an instance to invoke a class method. In my view, that's I think that's a bad thing. And it's a bad thing because before, when this was happening, if this would be allowed, if I look at that, you can't tell whether this is a class method or an instance method if I'm invoking it from the instance. If I see it being invoked from a class, there is only one thing it can be. I don't even need to look. It's the name of a class dot method. The only way that can work is if that's a class method. Okay, and let's just make sure it actually still works.
Can I just ask you some questions here?
Sure.
So previously we created a method within the main called mats. Is what you had crossed out right up there.
Well, no, I didn't create a method. I instantiated.
A method named mats.
No, an object.
Object.
Yeah. Again, yeah. So this is where let's unpack the syntax. So class variable. So this declares maths lowercase to be a variable of type maths.
Okay.
Right. New math says, okay, instantiate one of these guys, and then the assignment says assign it to this variable.
So maths had access to everything within your maths class.
Correct.
Okay. Then
Well, from this reference, I can invoke all the public things, in particular public methods. But from here, I can't, if there were an instance variable, I couldn't access it from here. If I kept it private, unless I made it public, which is a state of sin. But again, now this is red squiggly because private says that I can only create a maths object inside of here, inside of maths. Here I'm trying to do that. nuh-uh. So, but again, because this is one use of a class method is a pure function. Now, there's a pure function is something where I do, like adding two things together, multiplying them, maybe like some ones I've written, taking the inner product of two vectors, taking the scalar product of a vector, adding two vectors, things like that. Okay, so okay, here's a very common, or something that I've found to be very useful, use of static variables. And the idea, okay, so I'm defining a class called item, and I want it, eventually it'll have a whole bunch of stuff, but for now, I just want to have it, give it a name. And it's just going to have an ID, and the ID is going to be something that's unique. All right, so now now here's the thing, is that a common way to do this, by analogy to what we've done with the card, is to set them that way, and then remember we can kind of encapsulate our fields. Where are we here? Refactor, encapsulate fields. Now I only want to have getters on this, and let's put it as the last method. Okay. So now what's the weakness of this approach? Given that I want every item to be unique, and I want the IDs of every time I create one to be sequential. Does this class guarantee that behavior? Well, why not? Could you create multiple items with different names and the same ID? Absolutely. So this class does not guarantee that behavior. And the principle is that as much as possible, each class should make sure it's kind of protecting its variables. So this is kind of not, even though ID is encapsulated very well, that is, nobody can change it once I create it, I can't prevent somebody from doing something bad to it. Or, let me rephrase that. I can prevent somebody from doing something bad to it, but I can't prevent somebody instantiating ones that don't meet the criterion that I set. All right, so how can I do this? Well, this is where the static one per class kind of comes in. So instead of this, what I'm going to do is I'm going to define a static variable, and I'll call it next ID. And in fact, I'm going to, I'll do whatever you want on this. Are you okay with the zero base? So should the first one be zero, the first ID be 0, or the first one be 1? 1. Okay, 1 it is. Okay, now unlike instance, I'll talk more to this. Unlike instance variables, static variables, it's okay to initialize them on the same line. The other thing, and I'll hit this more later. Notice that it's all uppercase. That's the convention for static variables. Are meant to be uppercase. That's the convention. All right. So there's going to be just one of these per variable, per class. And now I'm not going to do this. I'm going to do this. And then I'm going to do that. Okay, so this puts together a number of things that I was saying. Now, remember, a constructor syntactically is like an instance variable. It's not a class variable, it's an instance variable. So what is this doing? As an instance variable, remember, an instance variable can see both instance and class variable. An instance method can see both class and instance variables. And as you can see, by virtue of no red squiggly, what this says is when I create an item, I'm just going to say what its name is, and the ID of that item is just going to be whatever the next ID happens to be. And because there's only one next ID variable, it's the only place it's going to change is every time I create a new one. Every time I create a new one, next ID is going to click up by one. So the first one I create is going to have ID 1. The second one is going to have ID 2. The third one is going to have ID 3, etc. And so now this class is guaranteeing that behavior. That is that is absolutely ironclad. The behavior that every item has a unique ID and that they will be created sequentially is guaranteed by this structure. And the fact that you have a static variable of which there's only one, and then instance variables for which there's one per object is what makes this work. And this is a very valuable pattern. Just to kind of.
Is it your rule that there's only one instance or one instance variable per class and one? Is that your, or is that a language constraint? Okay.
Say that again.
So you've said that you can only have one instance variable per
Object.
object.
That's the language.
That's the language.
That's the language. I mean, and one class variable per class. That's the language too. Yeah, but yeah, those aren't my rules, so don't blame me. I just use them. So, yeah, so that's built into and this wouldn't work if that weren't the case. And again, this is where a lot of these things kind of gel. And again, this is a small thing, but it's still something I found to be extremely useful.
Your string and your int, name and ID that are listed there are then just local variables.
No, they're instance variables.
Those are also listed.
Yeah. Yeah. Okay. How can I tell? Well, it's by where they're located. So an instance variable is defined outside of any method, but within the class.
So then, don't you have 3 instance variables?
I have 2 instance variables and a class variable. See, this is a class variable because it says static. And then this name here is a local variable.
There could only be one static within an item. You've already decided that's the next item.
Correct. That is, the next ID, there's going to be only one copy of that in the entire virtual machine. And it's going to live inside of item, and only item can change it. So I made it private, so if I made it public, then some other object could kind of reach in and change its value. But I want to prevent that. So by declaring it to be private, the item class is the only class that can change that value. It's the only class, and an instance is the only one that can change any one of these 3 values. Now, if I had a class method, I could access this variable if I wanted. But in this case, there's really no need. Okay, so
That could be any type of variable.
Yeah.
So I can have another
Oh, absolutely.
class or object there or something
Yeah,
like that as the one static.
What if we were to try to add another class variable?
I bet you the rest.
Yeah. Okay, what type do you want it to be? Okay, and here's a useful. Okay, so here I've again the type of a variable can be any type that you've defined. So it can be one of Java's types, and it could be a primitive type as we have here. It can be a Java built-in class like string, or it could be one that you've defined. So here's how we can actually use this. And let's put this together with what we talked about overloading constructors. So supposing I want to create an item, and I really don't, I don't care to give it a name. Correct. So in this case, if I say, okay, I just want to create an item, I don't care about the name, I'm willing, I don't worry about that, I'm just interested in other things about it. So under those circumstances, I say, well, I'm not going to make you give it a name if you're indifferent to it. And so, okay, so let's look at this. I've overloaded the constructor. This one has a signature string. This one has a signature empty. And remember the other rule, and this is my rule, based on good practices, that if I have multiple constructors, they should all call a master constructor, or they should all call another constructor and have only one call the super. So even though I haven't written it here, this is really what's going on. Okay. Now the last little issue is that well, by making it private, it doesn't really matter. But in this particular case, if I don't want this to change, I can actually add the keyword final. And what that says is that I can never actually change that. So if I were to try to do that, like that, it says cannot assign a value to a final variable. So that's just another little thing. So again, this is how you can have interactions between class variables and instance variables, and use them in a way that guarantees a certain type of behavior and doesn't rely on the kindness of strangers. So think of that phrase. If your objects working right and being configured correctly depends on the kindness of strangers, then newsflash, strangers aren't kind. So your mother was right. Don't talk to strangers. And the thing is that stranger may be you. That stranger may be you who've inadvertently done something. Okay, but what this does is this saves me from myself. This saves me from accidentally creating, with the IDs. It saves me from having to worry about making sure that I create them in the right way. And whoever creates these, that's the stranger. Now I'm kind of safe from the stranger. Okay, so that's